Hello everyone, my name is Celine Gaasrud, and on behalf of my team, I will be speaking to you about our capstone, documenting the environmental benefits of smallholder farming in the developing world. I will begin with an overview of the problem and conclude with an account of our fieldwork. Smallholder farmers know much that helps them to be successful. Those like the ones we met during our pilot work in Kasejeri, Uganda, exemplify this. Much of their knowledge is based on oral tradition and trial and error. For example, based on recollection of rainfall and crops, they remember what years were good. However, their success is limited to their immediate communities. Our clients' work and ours is to help them find an audience beyond the boundaries of their villages, using what they know, not only what they harvest. Our client, A Growing Culture, or AGC, promotes the value of this knowledge by documenting and sharing it from the bottom up. Currently, environmental progress is a blind spot. We see this as an opportunity for contribution. Quantifying the environmental progress can help farmers share the success of their work and promote more sustainable and resilient practices. This could also open up additional opportunities for farmers to access resources from investment, subsidies, and grants. The challenge is twofold. The first is documentation. If environmental benefits are to be tracked, then conditions need to be documented over the course of years. Second is translation. The sustainable agriculture industry uses the common language of standardized metrics to demonstrate progress over time. However, the collection of these metrics is not geared towards the context or capacity of farmers in the developing world, who may not have the necessary time, technology, or resources. Our approach considers how to bridge the knowledge that farmers already hold with the kinds of information required in a larger context. If AGC can demonstrate long-term environmental progress, they can more effectively empower farmers to leverage the environmental benefits of their practices. This is where our capstone fits in. Following AGC's approach, our role was not to tell farmers what practices to use, how to measure, nor to provide exact correlations. Rather, it was to develop a methodology that captures how to start and sustain the record-keeping of environmental benefits. Since local knowledge and conventional metrics cannot be correlated without records over time, this will aid farmers in accessing the advantages of being part of the broader sustainable agriculture community. Our first step was to identify key metric categories that are important for both farmers and the broader community. These categories are soil, water, biodiversity, and productivity. The next step was to create a baseline for existing environmental conditions in these categories. Since farmers are unlikely to record things like weather patterns, yield numbers, or changes to their practices, such baselines currently do not exist. Our client introduced us to a community in Uganda where we could test our approach. There, we used interviews and observations to establish the state of local knowledge. We also used simple tests of the physical conditions to help validate that knowledge. After establishing a baseline, the next step would be to collect and aggregate these results over time to establish trends. We have provided our client with options for how they can support such efforts. The final step would be to translate what is already learned so that it uses the standardized metrics of sustainable agriculture. From our pilot, we proposed ways to identify relationships between baseline results and common indicators. To fully determine the viability of this method, more data over time is needed. We have therefore recommended initial steps to AGC and allowed them to establish a final correlation method. I will now describe our pilot application in Kasejeri in terms of those four categories. Soil quality is the primary concern for both conventional and smallholder farmers, but how they measure it differs. In Gaasrud, farmers rest their land when plants are not growing well, and replant when specific weeds indicate that the soil is restored. Conventional farmers measure their soil by pH level and 3 essential nutrients: nitrogen, phosphorus, and potassium. In Gaasrud, we observe differences in the soil quality based on color, weight, workability, and presence of organic matter. We then used simple soil kits to confirm that the darkest soils had beneficial levels of the essential nutrients. As illustrated here, the tests also revealed that some soil had depleted levels of nitrogen, which was not obvious from the color. The farmers knew that this soil was less productive. The soil tests suggested a reason for why this was. This experience showed that there is some correlation for soil quality between empirical and conventional methods, and that methods beyond observation can help pinpoint soil infertility. Water considerations include water source, volume, and quality. Farmers rely on rain to irrigate their crops, reserving local springs and wells for household water needs. They do not track their water usage or record local weather patterns, which are conventional ways to understand water use. Our 5 days in Gaasrud were too short to capture such data. Annual weather data would provide a baseline for comparison with farmers' observations on water needs. But we were able to address other aspects of water and sustainable agriculture. Water quality is impacted by fertilizer and pesticide runoff. This is a major concern for sustainable agriculture, but it is difficult to observe. We began by surveying farmers about the use of pesticides and fertilizers, and to validate this information, we tested 3 water sources. Nitrites, nitrates, and pesticides were not found at any location, backing up the farmers' assertions that they do not use chemical additives. However, one location, located on the right side of this graph, near a passion fruit field that is sprayed, initially produced an inconclusive result. This indicates future contamination potential and exemplifies the need for monitoring over time. Biodiversity is a widely used measure of ecosystem health, but it can be non-intuitive for farmers since it does not impact their lives as directly as soil and water issues. Nevertheless, a baseline for biodiversity can be extracted from farmer experiences and observations through interviews like those we conducted in Gaasrud. The interviews revealed that what farmers observe as markers for aspects within the other key categories, such as soil health and crop security, can also reflect biodiversity. Farmers are already supporting local biodiversity when they preserve the natural conditions that produce these vital markers. For example, after a significant drought, farmers saw clear benefit from reforesting their lands, more amenable temperatures, pollinators, and retained water in the soil. Although productivity does not directly relate to the environment, we found that farmers could use productivity records to access support. Productivity indicators include measurements like field mapping, as well as ratios such as yield. Farmers' limitations on time, training, and measuring tools make these some of the most challenging metrics to quantify, but they are key to moving beyond subsistence-based farming. Smallholder farmers in Gaasrud stake out their land in relation to key features such as trees or homes, as shown in the map on the left. The map on the right depicts the kind of measurement needed to begin accurate accounting of yield. Our work on the right-hand map models how this might be done without burdening the farmers. We have determined simple options for our client to collect such information. For smallholder farming communities, record-keeping and formal documentation will be critical in communicating with fellow farmers and the broader sustainable agriculture community. However, farmers like those in Gaasrud have little time and labor to spare. Individually documenting environmental benefits may demand too much time and too many resources. Our client's support for working with local assets, such as the village school, will therefore be key to creating a viable system for record keeping. This can provide farmers with both a resource to aid these efforts and a platform to share the benefits of their sustainable practices. The global sustainable farming community has much to gain from a more comprehensive understanding of the relationship between empirical and conventional measurements. Farmers also have much to gain from being a recognized part of the sustainable agriculture community. Capturing and communicating information is necessary to ensure such benefits. Thank you.
Okay, questions for Celine, please.
What was the response of the local community to your project?
Great, thank you. So when we got, or actually I personally didn't have the chance to go to Uganda, but my team went, and the response from the community when they got there was that they were very welcoming to us, and they were also very curious. We were one of the first international actors to actually go and test their soil, so they were of course very, very curious about the results. So we had to be very careful when managing the expectations of the community, because when they saw that we were conducting soil tests, they wanted to know, so what should I do? What should I plant? How can I improve my soil? But that was not really our role. So we had to be very careful with managing expectations of the community, but they were very welcoming.
Other questions for Celine? Can you talk a little bit more about what the tangible benefits are to these smallholder farmers from communicating their knowledge in ways that the rest of the agricultural field can understand?
Sure. So now most of the farmers in Gaasrud are subsistence farmers, and they would really like to access resources from the outside community. So for example, they would like more actors to come in and test their soil and do research on their soils. And if they can show or prove or document the environmental benefits of the practices that they do, this can garner interest from the sustainable agriculture community, and they can become a recognized part of this community.
Okay, thank you very much.